Hello, let's talk about factoring quadratics. Factoring is opposite of distributing. So I want to remind you about distributing and what we would do if I wanted to distribute this problem. So we would do x times x, which is x squared, x times negative 6, which is negative 6x, 5 times x, which is 5x, and then 5 times negative 6, which is negative 30. And you might have been taught the word FOIL. This first term, x squared, that came about because those were the first two numbers that we multiplied, and they were the x times x. Those were each first in each parenthesis. This was O for the outer ones, the outermost ones, x and negative 6. I for inner, the innermost ones that are closest together, 5 times x got multiplied. And then L for last, the last numbers in each parenthesis got multiplied together to give us negative 30. So if we distribute or FOIL, then we always combine our like terms, and that would give us x squared minus x minus 30. So what do we do if we have x squared minus x minus 30, and I wanted to know how did it originally start off as parentheses? So that's what factoring is, and we're going to talk about that. And I'm going to just show you one way to do that. There are many ways to factor, but I'm going to show you just one way. We're going to take, if you notice that when we were doing the FOIL, the two numbers of our parenthesis, the 5 and the negative 6, when those two numbers got multiplied, we got this last number. We got the negative 30. So I did it again. I'm going to focus on that because that's going to help guide what numbers go in my parentheses. Okay? So when I'm doing this example here, I've got x squared plus x minus 20. I know that there were two numbers that multiplied to give me negative 20. And notice that those same two numbers, 5 and negative 6, those are the O and the I parts. They got multiplied by the x, and we combined those like terms. So those also had to add to get us this common term here, negative 1x. So I'm going to write that out in symbolic form. So when we're factoring something that looks like a x squared plus bx plus c, we need two numbers that multiply to equal c, and they also have to add, and I know they're going to add because this symbol says they're going to add. They're going to add to equal that b number. So like I started doing in this first example, I need two numbers that multiply to equal 20, and those same two numbers have to subtract. I know I'm subtracting because of that symbol. And when they subtract, they have to equal this middle term, that b term, which is 1. Okay, so let's think about two numbers that multiply to give me 20 and subtract to give me 1. So if you have a hard time coming up with that, what I suggest you do is just list all of the pairs of numbers that multiply to give you 20. So if I make a list of factors of 20, I've got 1 and 20, 2 and 10, 3 doesn't go into it, so I'm not going to include 3, 4 and 5, and that's the end of my list. So which pair, all of those pairs multiply to give me 20, but there's only one of them that subtracts to equal 1, and that's this pair. And remember that I want to equal positive 1, so when I subtract, if I do 4 minus 5, that would equal negative 1. But if I do 5 minus 4, that would equal positive 1. So I want this pair, not that pair. Okay, so what does all that mean? Well, it means that when I have the parentheses, I know that I'm going to have x and x, because remember, x times x is what gives me the x squared. But the numbers that appear are going to be positive 5, so plus 5, and then negative 4. And you can always check yourself to see if you did that correctly. So you can distribute to check yourself. So if I were to distribute, I would do x times x is x squared. X times negative 4 is negative 4x. 5 times x is 5x, and then 5 times negative 4 is negative 20. And then if these would combine, that would be x squared plus 1x minus 20. So yeah, that checks out. So this set of parentheses is how that quadratic looked in factored form. All right, let's do another one. So in this example 2, we are going to do the same idea. I'm going to look at my last term here. I need two numbers that multiply to equal 49, and those same two numbers have to add to equal negative 14. All right, so let's make a list of numbers. 49, well, I've got 1 and 49, and then I've got 7 and 7. Okay, so they need to add to give me 14. So I know that 7 and 7 are going to work, not 1 and 49. However, if I do 7 plus 7, that's going to give me positive 14. How would I make that come out to be negative 14? Well, that would be negative 7 plus negative 7. Okay, so when I'm supposing is that my answer, I'm going to have x times x. Remember, that's what gives me the x squared. And then these two numbers are going to be negative 7 and negative 7, or x minus 7 and x minus 7. Now, also, the book might write this as x minus 7 parentheses squared. Remember, that just means it's a parenthesis times itself. So just be aware that that might happen. And then again, if you wanted to double check yourself, let's say this is on a test or homework, you could distribute that out and see if you get the same thing. All right, so let's just do two more problems so you can see how this works. So I want two numbers that multiply to equal 1, and those same two numbers have to add to equal which number? Yes, the 2. All right, well, this is nice because numbers that multiply to give me 1, there's only two numbers, 1 times 1. All right, so I know that these have to equal 2, and if I do 1 plus 1, that equals 2. All right, so my two parentheses are each going to start with x, and then the numbers in them will be plus 1 and plus 1. I know that they're going to be both positive because we want them to add to equal positive 2. So that could be my answer, or remember, we could also write that as x plus 1 squared since they're both the exact same parenthesis. And then we've got one more. So we want to do numbers that multiply to equal 40. And then they also have to subtract to equal negative 3. All right, so let's make a list of factors of 40. So I've got 1 and 40. I've got 2 and 20. Does 3 go into it? No. 3 is not a factor of 40. So let's go up to 4. 4 times 10, and then 5 times 8. And then does 6 go into 40? No. So that's not going to be on my list, and 7 does not either. So once I get to 8, 8's already on my list, and I know I'm done. All right, so those are all the pairs that multiply to give me 40. Now we need to see which pair also subtracts to give me negative 3. Well, this pair is the only pair that's going to subtract to equal 3. And we want negative 3, right? So if I do 5 minus 8, that's going to give me negative 3. I don't want the vice versa. I don't want 8 minus 5. That would give me positive 3. So I don't want that one. I want a positive 5 and a negative 8. So when I put this in my parentheses, I want x plus 5, and then I want another x minus 8. So that's how we take our numbers and turn them into factors of quadratics, and we will do a lot more with factoring later on in class.